Okay, students, so today we start with our new and very interesting topic, heat and temperature. So heat and temperature both are different things. First, we will define heat. What is heat? So heat is a form of energy which is transferred between two bodies due to difference in their temperature. And heat energy always flow from a body at higher temperature to a body at lower temperature, right? It's not possible for the heat to transfer from the lower temperature to the higher temperature automatically. Simultaneously, automatically, heat always flow from higher temperature to lower temperature. We need not to make any uh, tool to help the heat to make it flow from higher temperature to lower temperature. Automatically, it will flow from the higher temperature to the lower temperature. It's a automatic process. So you can see in the picture, heat always flow from higher temperature to the lower temperature. So this arrow represent the direction of flow of heat, which is from higher temperature to lower temperature. I cannot reverse this arrow. So if we want to reverse the arrow, we need to take the help of some external engine, external machine, external tool. So with the help of external tool, it is possible to make the flow of heat from lower temperature to the higher temperature, right? Like we are doing in the case of AC. The temperature of the room is very, very high and we want to make the temperature low. So what we are doing, we are just switching on our AC. So what AC will do, AC will throw the heat, means the cool air, which is at lower temperature, into the room, which is at the higher temperature. So to transfer the heat from the lower temperature to the higher temperature, we take the help of a compressor. But when the heat is transferring from the higher temperature to the lower temperature, then we need not to take the help of any compressor or any machine, right? So transfer of heat from higher temperature to the lower temperature, it's an automatic process. Need not to take the help of any machine, need not to take the help of any tool. But to make the flow of heat from the lower temperature to the higher temperature, we need to take the help of a compressor. We need to take the help of external machine. We need to take the help of external work. External force is required, right? Now, what is temperature? Now, already we discussed about heat. Now, what is temperature? Temperature is a very important and very interesting thing in this chapter. So temperature is a physical quantity which measure the degree of hotness or coldness of a body. How hot and how cold a body is, it is measured or it is defined with the help of a physical quantity which is called temperature. It can also be defined as the thermal condition between, it is the thermal condition of a body which determine its ability to transfer heat to other body. So temperature is that thermal condition by which we can measure or we can analyze the transfer of heat between the two bodies. If the two bodies, they are at the same temperature, then it's not possible to make the transfer of heat. But if the two bodies, they are at different temperature, then we can expect the transfer of heat between the two bodies, right? So temperature, it is the property which determines the direction of flow of heat between the two bodies in the thermal contact with each other. When the two bodies, they are in thermal contact with each other, then definitely the heat will flow from the higher temperature to the lower temperature. So the flow of heat, that indicates, automatically it indicates that the two bodies, they are at different temperature. If the flow of heat is taking place, then definitely we can say the two bodies in contact, they are at the different temperature. And if there is no flow of heat between the two bodies, then we can say very clearly that the two bodies, they are in thermal equilibrium. They are in thermal equilibrium. So here the term is thermal equilibrium. So thermal equilibrium is, it is that point at which the two bodies, they maintain the same temperature. Thermal equilibrium is that stage at which there is no exchange of heat between the two bodies. So thermal equilibrium is a very, very important term which represents that the two bodies, they are at the same temperature. The two bodies, they are not exchanging any heat between them, right? So it is the property which determines the direction of flow of heat between the two bodies in thermal contact with each other. And we know that the direction of flow of heat, that is from higher temperature to the lower temperature. So the arrow, the direction, that will be from higher temperature to the lower temperature. When two bodies are at the same temperature, then they are said to be in thermal equilibrium. Already I told you what is thermal equilibrium. Thermal equilibrium means the two bodies, they are at the same temperature. When they are at the same temperature, then there is no flow of heat. There is no exchange of heat between the two bodies. So that stage is called thermal equilibrium. Very, very important term. And temperature is the macroscopic property of a body or a system. It's not a microscopic property. Microscopic property means in the microscopic property, basically we study about the velocity of the body, the kinetic energy associated with the body, the momentum of a body. But when we are dealing with the macroscopic property means the pressure of the body, the temperature of the body, the volume of the body, that is called the macroscopic property. So temperature is one of the macroscopic property. I repeat it again, the macroscopic properties, they are pressure, volume, and temperature. And the microscopic properties, they are velocity, they are kinetic energy, they are momentum of a body or a particle. So temperature is a scalar physical quantity. What is the meaning of scalar physical quantity? Scalar physical quantity means let me give you one example. Suppose we have a candle and it is emitting both heat and light. So we never talk about that. What is the direction of flow of heat from the candle? What is the direction of flow? Because the heat is flowing everywhere, 0 to 360 degree, uniformly everywhere around the candle. So we never talk about the direction of flow of heat. So we never talk about the direction of flow of temperature. Okay, so around the candle, you measure the temperature in any direction, you measure the temperature. We never mention any particular direction of the temperature, because temperature is everywhere. Temperature is everywhere around the candle. Temperature is everywhere around any light or heat emitting source. Temperature is everywhere. Temperature is everywhere around a bulb. So bulb is also a source of light and heat. It is emitting the heat. So we never say that in this particular direction we will find the temperature only. It is present everywhere in all the directions. So temperature is said to be a scalar physical quantity. Now let me illustrate some differences between the temperature and the heat. And the first difference is temperature is the thermal condition that determines the direction of flow of heat. Already we discussed it. It is that condition that determines the flow of heat. So if the temperature is same between the two bodies, then definitely we can say that there is no flow of heat. Now what is heat? Heat is energy transferred from higher temperature to the lower temperature, right? So heat is the result of difference in temperature. If the difference is in temperature is there, then there is a flow of heat. Temperature is average energy of the particles, and heat is the total energy of particles. Temperature is average energy. Note this point. It is average energy of the particles. Means suppose we have 10 particles. Every particle that contains the energy. So what we will do, we will add all the 10 particles energy from E1, E2, E3 up to E10. Add all the energies and divide by 10. So that is the temperature. So temperature is average energy of the particles. If we have n number of particles, then every particles contain energy E. So we will do E1 plus, so E plus E plus E plus E up to nth particle, and then we will divide it by n. So that is called the average energy. Sum of all the energies of the particles divided by total number of particles. That is called the average energy, and that will give the temperature. But heat is the total energy of the particle. Total energy means we will add all the energy of the particles, but we will not divide it by the total number of particles, right? Temperature is degree of hotness, how hot the body is, or we can say how cold the body is. So temperature is the measure of hotness as well as coldness of a body. Degree of hotness or a degree of coldness of a body, that indicates the temperature of the body. But heat is the form of energy. It's only the form of energy. It's an energy flow from higher temperature to the lower temperature. The unit of temperature are Celsius, we can take Kelvin, or we can take Fahrenheit. These are the units of temperature, and the unit of heat is joule or calories. Okay, so these are the major differences. There are so many other differences between temperature and heat, but the main differences which we are required, they are indicated over here. So difference between temperature and heat. Now we have some questions, multiple choice questions, and the first question is, heat is a form of energy transferred between two bodies due to difference in energy. No. Temperature, yes. So option B is correct. Heat is a form of energy transferred between two bodies due to difference in temperature. So I will just end up over here because at 11:45 there is a career counseling session of class 8. Okay, so that's all for today. I will send you the link of this video in your group. Okay, Simran, Ishant, Pankaj, that's all for today.
Yes, sir.
Okay.